everyone. My name's Emily Morandini. I work as the Technology Programs Coordinator over at the Learning Space, which is just across the way. You would have seen it on the way in. So I'd like to thank everyone for coming today, and thank you to our two speakers, Maria and Alex. First of all, I would like to acknowledge the Wongal people of the Eora Nation and pay my respects to elders past, present. So pay my respects to them as the custodians and traditional owners of the land in which we meet today. So I just wanted to do a really quick introduction just to sort of contextualise this talk today. It was put together and organised by Vaughan, basically, who's one of our technology program officers at the Learning Space. So we are part of the City of Canada Bay Library Services. If you've been into the venue next door, you'll see it looks pretty much like a study space, but in reality we do run a lot of workshops online of recent, but also in person, and we do like to give pretty much equitable access to different technologies, and we do run a lot of technology-based workshops. So one of those is 3D Print Club, which has been one of our most regular programs since we opened. So this talk pretty much comes out of working with a lot of local hobbyists, really, who do 3D printing, but are also just interested in design and modelling and just getting together and having a bit of fun, really. But Vaughan comes from a background of basically an artist, researcher in, I guess, architectural design.
Sort of, yeah.
Sort of. So when he saw the project of the living seawall, he immediately was on it and was super keen to find out more about it, and just immediately got in touch with these guys because he thought it was just something that tied in beautifully with the sort of programs we run, but also it is a local project about the local environment. Obviously we sit right here on the shoreline, so it's sort of brings together a focus on community, environment, and how sort of technology can be involved with, making things a bit better, ecologically speaking, but also the applications of this technology. So anyway, I just wanted to give an introduction to that. Vaughan, if you would like to introduce our speakers today.
Thanks, Em. So joining us today, we've got Dr. Maria Vozzo from Sydney Institute of Marine Science, and Alex Goad of Reef Design Lab. So the kind of context of this talk is really, I guess, my thinking about it and my interest in hearing from both of these guys about the Living Seawalls project is really anchored in my kind of engagement and thinking around 3D printing and the environment more generally as well. And I guess it's really considering the sort of moment that we're in terms of 3D printing, in terms of it being a bit like, and digital fabrication more broadly as well, it's kind of reached a kind of a point of maturity in terms of it being not just about the sort of novelty of producing like little plastic trinkets. That's kind of, that moment of 3D printing has kind of come and gone. And so it's really interesting to see projects like this that are starting to think about the materials and the design approach and the kind of environmental impact and possibilities of using 3D printing outside of just kind of like perhaps the more introductory, kind of the first wave of innovation that came about in 3D printing several years ago. So to kind of lead into this project, to hear more about the background of the project, It'd be great to hear from Alex and Maria, just in terms of like what caused this project to sort of come to exist in the first place, and kind of like maybe give us a bit of a taste of like what is the Living Seawall project.
Yeah, thanks for that, Vaughn. I guess just one thing before I begin, I just want to point out that Alex and I are just two members of a very large group of researchers working on this. So we have partners at UNSW and Macquarie University as well. So what we're talking about will be things that we're all working on together, not just the two of us. So yeah, I think maybe one thing to kind of put it into context is when you think of the term urban sprawl, what comes to mind? You might be thinking of, loss of parks on land, developments on land, but actually that's happening in the marine environment as well. We just don't see it. And so that has large implications for marine biodiversity. Did I click it?
Very strange.
Oh, maybe if you use the arrow or up or down arrows.
Sorry guys, we've got all of the technologies.
There we go, that's what I was talking about. Yeah, so in Sydney Harbour actually, over half of the Sydney Harbour shoreline has been modified with artificial structures. So things like seawalls, pilings, wharves, and jetties, all things that we rely on for our way of life here in the harbour. But that's actually resulted in a loss of natural habitats. So we often will look at, I think the font's a bit messed up here, but we'll often compare what's living on natural rocky shorelines to what's living on seawalls, because they're very similar in terms of the materials that they often are comprised of. And so as you can see in this picture, a natural shoreline has a lot of intertidal space. It's a very gradual slope, and it contains things like rock pools and crevices that are really important for marine life. Whereas infrastructure, so things like seawalls, don't have that. They're relatively flat and featureless, and it makes it really hard for marine species to survive on those structures. So I guess kind of going back to your question, we already have over half of our shoreline here modified, and we can't remove these structures. So what can we actually do to try to improve the ecological value of those structures? And that's kind of where Living Seawalls started a few years ago. So I can let Alex maybe speak to that.
Yeah, so look, thanks for having me, guys. As Maria said, the Living Seawalls project is a fantastic collaboration between so many different organizations and people. And really it came about from, I got involved in this program in 2015, but the project really builds on kind of decades of research done by scientists from SIMS. So we were actually contacted by Dr. Beth Strain in 2015 to sort of be producers of these panels that they wanted to test. And then that was we were already doing, a couple of different projects using 3D printing to create artificial reefs and that sort of thing. And we sort of said, well, this is a perfect opportunity to use, desktop 3D printing, just using, FDM printing to kind of create these various geometries. And that way we can really test some much more natural looking forms really economically using, a combination of FDM printing and rubber molding. So yeah, the project's really kind of grown. It started with just producing a really simple 250 millimeter square panel to now producing these much larger panels. And now, as the research develops, we are sort of starting to go larger and larger.
Yeah, and actually I have a slide that is next that kind of illustrates some of that legacy of green or eco-engineering in Sydney Harbour. So you'll see on the left some of the very first interventions were actually just leaving blocks out of the seawall that would then create pools. Then we started to look at, well, if we already have an existing seawall, what can we do to retrofit that? We added these half flower pots, we being researchers before me, but just again, knowledge that's led to the project. And then what Alex was referring to are on the right, these smaller square panels that we use to test how we can manipulate complexity and what that does to marine biodiversity, which then has led us into scaling up into these larger designs that are all based on nature, which we're pretty proud about. Uh-oh. Okay. Yeah, I can go through them if you want, or do you want?
Oh yeah, cool.
Yeah.
Just in terms of so these are the panels that are currently installed at Sawmiller's Point and in the City of Canada Bay around the Drummoyne Wharf.
Yes, that's correct. And yeah, Alex, you can jump in whenever you want if I'm just showing the different panel designs. So yeah, as you can see on the slide, so one thing that we're really quite proud about and what we're able to do using 3D printing technology is that we can get these really nice geometries that are based on designs we see in nature. So my colleagues actually went out and looked at these features on natural shorelines, measured them, were able to provide these dimensions to Alex, and that's how we could come up with these designs. So we have panels that mimic the weathering patterns of sandstone, so things like the honeycomb pattern and the crevices pattern. We know that small fish like to kind of hide in little areas. So we have the swim through panels that are actually holes that go through the panel that we see little fish sitting in them and looking at us while we're doing our surveys. And then we have the rock pool panels. So on artificial structures, as I mentioned before, they're usually very flat and featureless, and they don't retain any water. So when the tide drops, that's an extremely harsh environment for these species to try to survive in. And so what all these panels do, and especially the rock pools, is they'll retain water and moisture and provide a cooler environment so these panels can survive these species can survive on the panels during low tide.
Amazing. The design for these, I guess, looking at them, there's a really beautiful thing about digital fabrication as well as the way that it seems to sort of bridge the kind of digital and material world in really exciting ways, especially in terms of like computational design processes and that sort of thing. In terms of your design process for these kind of panels, what does that look like from your end, Alex?
Yeah, so as Maria was saying, we kind of work very collaboratively to come up with the designs, and I've been given a lot of information about what has been found naturally on existing rocky shorelines. So we then, it's kind of a bit of a traditional process. We'll start sketching various ideas, but we'll very quickly go straight into Cad modeling. And we use a mixture of different, Cad modeling programs, whether it's sort of Rhino or Grasshopper. And I use a lot of Maya and Fusion 360 as well. So, all of what we've done so far is relatively sort of simple things to model. We'll immediately start, modeling it up and kind of, there's a constant dialogue between our group and the scientists to make sure that that's going to fit, the research criteria. But then, of course, always looking at, well, what can we actually mold economically? Because that's something that's been so important for this project. It's not just a kind of one-off, art piece. We've literally produced I think it must be almost over 1,000 of these panels now. We really have to look at, well, what's a highly economical way that we can produce all these really, beautiful designs. So that's a major part of, I guess, the design process. And, that is really constant 3D printing and test molding to make sure that we can achieve the undercuts without, molds breaking and that sort of thing. We also do a lot of research into mold materials. So, the various kind of rubbers that we'll use, we've done 3 years of research into these materials to make sure that they will last, multiple years. And I think that's really important because, kind of the long-term point of this project is that we want to be able to incorporate these designs into marine infrastructure potentially. So we kind of need to have that knowledge of how we can, really economically produce these kind of forms. That's kind of the main process really. And then it's always a bit of a risk, when we actually do a full-scale panel, because there's quite a lot of printing that goes into it and quite a lot of money and kind of molding rubber. And, we're always a bit nervous if it doesn't work. But yeah, I mean, really, 3D printing's been fantastic as well because, we can print scale models like so economically and actually test them with the materials. So so a lot of kind of just, traditional prototyping that goes into what we're doing.
Great. In terms of how that's kind of, how that relationship has worked with Sims as well, how is that kind of, what do you think in terms of this collaborative process, what do you think Sims and kind of conversely with Alex, what do you think both parties have taken away from this collaboration? What's kind of like, how has it maybe changed your design practice, but also like what's been the ongoing dialogue and the kind of result of this collaboration, or what do you feel you've kind of taken away from this collaboration?
Sure.
Yeah.
Well, I mean, also.
No, you can go first, Alex. It's both of us. You can start.
I mean, look, the whole point of what we're doing we wouldn't be doing it if it wasn't for Sims. The research is so critical, to what we're doing. So, I mean, realistically, we probably, I think, we wouldn't have had the opportunity to test as many things as we had if it wasn't for Sims. So Sims has really been driving all of this work. So it's just been a fantastic collaboration because, we've had the opportunity to push these sort of different, this kind of design language in this weird intertidal environment. We wouldn't be able to do that without Sims. So it's been, a fantastic, collaborative and really exciting project for us.
And I think from the ecology perspective, traditionally ecologists just go to the hardware store, go to Bunnings and grab some PVC and some blocks and figure out what they can make on their own to try to test their research questions. And by working with Alex and, collaborating with such sophisticated design technology, we can create these beautiful structures. And that's just, most scientists haven't been able to do that before for this type of work we do. So I think that's really why this project catches the eye of a lot of people, stakeholders, general public. I don't know if Alex has put it in this talk, but his work's been featured in museums around the world. So it just is, I think people really appreciate that kind of bringing two very different fields together to solve this really major issue in an ecologically valuable and then also aesthetically pleasing way. So, yeah.
Yeah, I think that just sort of reminded me of something as well. Like, I think we've been able to have this opportunity to almost, develop this kind of design language in this area, but it's such an important thing that we formed because it is actually backed up by research. And I think that, both of the design and the research really, I think the design can really help communicate the research really well. And I think that's probably, for me, one of the most, the best part of the project is design is such a great communication tool, and it is communicating this really interesting and really important research.
And I've just popped up on the screen, just for scale, that's me in the photo. This is Alex's photo he took of us in the field one day. So they're quite large, these panels. So when we were speaking about the design process and the molding, you can kind of see what he was referring to with getting those molds to work.
What I think is really interesting with this project as well is, and you kind of both touched on it, is the fact that it's they're like such aesthetic objects, but almost their placement is also in some ways kind of a bit invisible, and it's kind of made to sort of blend into the background and blend into the environment. So I thought that was a really I just thought that was something of ours breaking. I just thought that was a really interesting point as well, that it's this kind of designed object that also just like folds back into nature, and in many ways it's kind of like an unseen thing as well. It's not potentially that visible within most people's kind of everyday experience, unless they're kind of on a ferry route or something like that, or they're a keen like diver or something like that.
Yeah, that's very true. And actually, we often kind of say, well, if they're successful, you won't see them very soon because they'll be covered in marine life, and that's the point of them. So this photo here, I believe, was taken maybe about 3 months after they were installed. So you can see that they're kind of turning brown from the natural recruitment process happening on the panels. That's just after they were installed. So you can see how clean the concrete is just after installation. And then I think, Alex, you had a few photos more recently in here. Yeah, so this is just after 2 years. And so you can kind of see that, we've zoomed into focus on the panels, but really the zonation on them matches what you would see in a natural shoreline. And as you said, if you were just passing on a ferry, you might not even notice them because they've kind of blended in with the existing structure. But yeah, you can see kelp and oysters and all sorts of algae growing on them. So they've been quite successful, which we're happy about.
So in terms of like research outcomes for SIMS, and in terms of like the overall like scope and sort of aims for these panels, what's the sort of end goal? What was the kind of the ambition for the production of these panels? What was the kind of initial what did that look like in terms of a brief or kind of like a hypothesis, to use a very maybe that's not the right term for it, but what was that kind of, what did that look like from SIMS?
Yeah, so what first started this collaboration is that we needed a solution for the kilometers of infrastructure we have around the harbor already. But I guess in the process, we're not advocating for building structures and putting these panels on because it solves the problem and everything's great. Really, we're trying to also create awareness about marine urban sprawl and what that's doing in our environment. We're going to increasingly rely on these structures in the future. So when a structure must be built, to try to consider incorporating ecologically friendly principles at the very beginning, or there's a lot of research now that shows that you can actually use other living things, so things like oyster reefs, mangrove, salt marsh, to serve some of these same purposes as marine structures. So where that's possible, we encourage the use of that. So it's about also creating awareness of the issue, and then again providing a solution that if you have a structure built, this is what you can do to improve the ecological value. If you must build something new, try to include these principles. Anything else, Alex, to add to that?
No, I think one of the key points there as well is, you're absolutely right. We don't want this kind of work to be used, as an excuse to build some massive, kind of damaging seawall infrastructure project. So that's really why, the kind of design language that we've been talking about, that's why it is so connected to the research, and we don't want these kind of projects to be involved in, a development that is really damaging at its very sort of most basic outcomes. So that's why, as we progress and, as we develop kind of further products and solutions for this sort of thing, we always want to be very careful that it's not going to be used in a way that just greenwashes an infrastructure project.
Nice. That's kind of an interesting, I guess, take in that as well, where there's always that potential that in the kind of the seductive biomimicry and the kind of computational aesthetics of the works as well, that it could be very easy to go down that path of almost trying to replicate nature in this kind of very synthetic, highly sort of scientific approach. So it's kind of it's very nice to hear that there's this kind of critical awareness of the broader sort of issue at stake, and this kind of this real, almost a real softness of approach that's, I think, quite lovely in terms of the sensitivity to the environment and context. In terms of the awareness aspect and talking about this almost as I think Alex was mentioning, in terms of communication and awareness, it's interesting to think of these in that as design objects that communicate this issue and as both they're kind of like immediate function, but also something that draws awareness to this wider issue through the aesthetics and through all these other sort of things. What has the kind of community reception or the kind of reception of these been? Has that filtered through to you guys yet? Or
yeah, it has. And actually, I'll just put up a slide that shows the installations we have around the harbour, so potentially people here have seen them. A map of it, actually. So we've actually run a few stakeholder workshops, though. In the process of getting approval for most of the installations, we've engaged with the local community, had to provide different review of environmental factor kind of documents, stakeholder consultation, and for the most part, people have been quite receptive. I think again, it's like a kind of a feel-good story. It's something that you can do and you can see it in your own backyard. So just kind of flicking through some of the different ones we have. This one's in McMahon's Point. This one's in Milson's Point, Balmain East, and then this one's just over in Drummoyne, so just in the Canada Bay Council. So people tend to like the project. People often have questions about how they're installed, how they're designed, and so I think that's really great that we can present that here to this audience as well, and answer some of those questions that people might have. So yeah, anything else, Alex?
No, I mean, I think that's great. Yeah, we have had, a lot of interest from overseas as well. A lot of kind of councils, as far away as Wales that want to purchase some of these panels and start testing in their environments. So I mean, I think that's kind of some sort of sign of success that the project has, really reached the other side of the world, and lots of people are very interested in it. And I think, I think we're quite interested in like how projects like this could potentially be very much open source as well. I mean, there are clear kind of commercial outcomes from this sort of work, but very much in keeping with the sort of maker, 3D printing community, I really like the idea that this kind of thing could be something that could be open source and could be trialed, in areas around the world. So yeah, I mean, I think the project's been really effective in that regard.
Amazing. So just to kind of dig into that, to ask the super nerdy question, I'm just kind of also fulfilling my own interest here. Alex, in terms of your kind of workflow in as to like, not to give away any, obviously, like if there's, parts of the process that are, proprietary to your design practice, don't go there, but it'd be really interesting to hear a bit more about your workflow in terms of like how these are actually produced, and it kind of like, what does that look like in your workshop, or are they kind of like locally produced, or is it kind of more of a mass produced product, or?
So, so I mean, I can run you through the whole process. Nothing's secretive at all. I mean, we shifted into quite a large warehouse at the start of last year, right in time for COVID, which was actually quite good because I could spend the time sort of doing things up. But we built, an entire little room that is dedicated just to FDM printing. And you can kind of see that through the little window behind my office. And so, we have a range of, various just kind of FDM printers that really, are not that expensive, to invest in, brand new. So we have a range of those sort of printers, and we do all of the printing in-house. And, once we kind of print the form, we then use a rubber sort of molding material to, cast over that. And then that, rubber mold, which, has all of the 3D printing kind of details, all of the 3D printing contour, extrusion marks, that then is used to reproduce the panels in various concrete mixes. So that stage of the process, we actually work with a great precaster here in Melbourne, and they actually cast the panels for us kind of, at an almost industrial scale. But this way we're able to, test various concrete mixes. We've already started testing various recycled aggregates, recycled shell. There's so many different things, and having these molding systems is a great way for us to kind of prepare for the future as well, to prepare for what, different materials could be used, in kind of what we would like to do in the near future, which is much larger scale marine infrastructure projects. So yeah.
Should I just show some of the close-up photos Alex has provided of the? I'm just showing the photo of the four different designs. So in this, you can kind of see the different contours he was talking about, and that comes through, from in the molding process.
Yeah, so that's what's really cool is, it almost looks like these are just directly 3D printed, and that's just a photo taken of the actual print, but that's just using the, the molding material. And that's what's really been cool about this project as well is, we sort of found that those 3D printed layers, have created a really great kind of rough surface for, small colonizing organisms to grab onto. And so, I think the 3D printing world is always looking at, okay, what's the best sort of the most detailed, the smallest layer thickness you can get out of a print. Whereas I'm always kind of looking at, how can we make it like as rough as possible and, print with as much kind of variation as possible, but still be able to get the kind of detail that we want and like all the overhangs that we want as well. So, that's been an interesting kind of, not really technical challenge, but just an interesting kind of, investigation into form. Whereas, we don't want to go sort of quite to like clay extruding 3D printing, for example, because you can't really achieve massive overhangs without things really drooping down. And so, FDM printing has been fantastic for us. It's kind of cool because, we're able to replicate, like it takes such a long time for anyone who does printing. That sounds like lots of people do 3D printing there. But, you can imagine, how long it takes just to print one thing. And it's just, one of these panels to print is something like 100 hours of printing or something like that. And, so for us to then be able to just multiply that like almost endlessly is really exciting to see all of these, replicated printed forms with still all of that detail all over the seawalls. It's really kind of an exciting process.
That's really great, though. I think that's a really interesting approach and a really great one when talking about 3D printing of really embracing the kind of the errors and the stuff that really often for in a kind of purist sense, maybe it's like the stuff that you really want to hide, almost like the layering and the contours and all that sort of stuff. It's really interesting to see how that features so heavily, and it's almost becomes again like an aesthetic, like in some of the imagery, like this kind of stuff. It's really quite has a sort of lends a really sort of particular aesthetic to the pieces, and it's kind of nice that that's almost like a unintentional thing that's kind of come out through this kind of in some ways quite lo-fi process.
Yeah, it's kind of like I've always been obsessed with those like architectural models where they do, the landscape in sort of contoured form. So it's kind of like every single panel is almost this like sort of contoured form landscape, which is sort of, it's like a childhood dream of mine to have a bunch of those models.
The marine life loves it. They love settling onto those, like the roughness of it. So it's actually, it works well for everyone.
I think the other key thing with a lot of this as well, and really what is kind of the main thing that our studio does is also that combination of 3D printing with traditional like molding techniques. So, I mean, that's been really key to this project as well, because we wouldn't be able to, replicate everything at, economically if it wasn't for that, combination of digital fabrication and traditional fabrication. So that's really, what our workshop is kind of dedicated to as well. The actual 3D printing component it's quite a small kind of room. The rest of the shop is completely dedicated to, a lot more kind of traditional techniques, whether it's metalworking, sort of traditional molding with fiberglass and that sort of thing. So it's a real mix. It's a real kind of maker space type workshop.
That's really great. And I think that's in some ways, really key feature of a lot of kind of post-hype 3D printing applications, but also in kind of digital fabrication more broadly is this idea of like hybrid crafting, where it's bringing those processes in sort of dialogue, the traditional making processes, as well as the kind of the contributions of quite high-end computational processes, and then the kind of but I think that the kind of nice thing in that context as well is the way that things like errors, and in this work, that sort of becomes part of the mix as well. It kind of contributes this sort of, indeterminate, unknown thing that in some ways presents real opportunity and kind of, serendipitous things in a project like this as well. In terms of the material aspect, so you mentioned briefly clay as well. Have you played around much with other sort of forms of digital fabrication for these panels, or is it just mainly just kind of going hard with the FDM printing?
So, I mean, we have, played with other 3D printing technologies for other projects, but the detail that, we wanted to achieve for the Living Seawalls project, just, traditional FDM extrusion is the best technology, I think, and the most economical to use. You could, of course, use, resin 3D printing and that sort of thing, but it's just kind of, I think, unnecessary for, it's extremely expensive to print something at this sort of size. But, in saying that, we have done some tests with Sims researchers where we needed to produce a 0.5 millimeter kind of groove. So for that project, we had to use, resin printing to achieve that kind of detail. And then we use, again, various of the same sort of traditional molding technology to then reproduce that.
Do you have a slide of that, Alex? Is there a certain slide to show that?
Oh, no, I actually don't have those. Those were just those little panels that we did for Nina. So, but in terms of other like printing technology that we've tried, there's a slide there, Maria, that's I think a bit further along, but it looks at some of the larger scale artificial reef units that we've done. That project. So, I mean, that's a really interesting, this is called D-shape 3D printing. And this was originally used, I think, back in 2010 or 2012, but there was a group that consisted of actually the original co-founder of Reef Design Lab, Dave Lennon, Reef Arabia, also an architect called Dr. James Gardner from Sydney, who they sort of collaborated with Enrico Dini, who invented this D-shape 3D printing process to create the very first 3D printed reef in Bahrain. So this is a really interesting, like, it's kind of sand bed, 3D printing technique. So it lets you, achieve kind of massive overhangs. You have basically no limit to the geometry in terms of overhangs and that sort of thing. So I collaborated with the World Wildlife Fund Netherlands in 2017 to produce these units for them to test how artificial reefs like this could be used for oyster restoration in the North Sea. So, you know, these units were using that technology. I think that still has a long way to go to kind of achieve any real detail. I mean, you can see with the units, they're relatively simple, and I think the tolerance on them is like something like 2 centimeters. So these units, when they were printed, they were a bit skinnier. If you actually go to the next slide, you can see the geometry was actually supposed to be a bit thinner, but it kind of, the units expanded as they printed a bit. So, I mean, and actually the design of that unit was quite interesting because you can't incorporate any reinforcing into the product. We had to design a lifting mechanism that actually, you know, lifted the bulk of the unit from underneath, but also wouldn't sort of slip off the lifting ropes and that sort of thing. So, look, that was an interesting example of, you know, a completely different 3D printing technology that is like, you know, the product that's printed is the product. But I think this sort of technology will have like amazing applications in the future. You know, if you can imagine, like low-lying islands could have one of these printers and use local sand to print, you know, coastal defenses with and that sort of thing. But yeah, I think that the technology still has a long way to go for that, like very harsh kind of commercial application. But that's, yeah, I mean, I think it's cool, a fascinating process. I mean, one other, you know, process that we use as well for like the Mars system, which is, you know, this modular system for that we designed for coral farming. Yeah, this system uses a similar process to the Living Seawalls project, where we, you know, use FDM printing to actually create the master, and then from that we create like a slip casting mold. And then these units are just cast in ceramic, you know, so it's again quite economical to reproduce them. And this was, yeah, kind of an early design for how you could build these kind of modular systems underwater for coral farming. But you can imagine how this kind of, I guess this is what Maria and I were sort of talking about as well in terms of like future concepts for the Living Seawalls project. You can imagine how systems like this could be used to, you know, further like bring out a lot of this geometry from the seawall to kind of go further back towards those natural rocky sort of shorelines. So yeah, I think it's going to be exciting on how we could potentially do that in the future as well.
Yeah, I actually had that as a question for you guys in terms of what do you see as the kind of future opportunities for this approach, for either in the practice of Reef Design Lab, but also in terms of like Sims or the kind of Living Seawall project. What do you see as the future for this kind of technology or this kind of approach?
Yeah, so kind of going back to the comment earlier about, you know, creating awareness of the issue. So going forward, now that we kind of have these examples of what can be done, trying to, rather than retrofit existing structures, actually build structures, again, where they must be built with these principles in mind. So I don't have a photo of it here, but I don't know if you're familiar with the Bahrain foreshore, that sloping kind of sandstone rock area. So that's a really great example. They just use sandstone blocks. There's no 3D printing technology with that, but actually thinking about what can we do to try to maximize the complexity of this, what would otherwise be a very unnatural, flat, featureless area, and trying to think about how we can, as Alex said, kind of extend that from what would have been the traditional kind of seawall into, more three-dimensional complex structures. So we've we have some ideas that we're working on with Alex, and hope to be able to get those fabricated and installed. And you know, just kind of a side note, part of what we weren't really expecting with this project was actually navigating some of that approval process. Because it was a very new concept, we kind of found ourselves in this in-between land of, well, it's not a development on land, it's not really going to be, you know, on the sea floor. we're not really sure who gets to decide what happens on the seawall. So trying to navigate that process has been quite slow. But going forward, having some precedent and some examples of how we can do this. And there's a few other projects from the harbour that we've been involved in that are really showcase how effective it is. So that should be easier going forward as well. Alex, do you want to add anything?
Yeah, no, I think, that's right. I feel like we've really done a lot of, the backup work to kind of going forward. I think it's been really important to do the Living Seawalls project so that, we actually do have some hard, data that we can use, to incorporate into much larger sort of designs. So, I feel like we've kind of done a lot of, the difficult work, especially Maria. Maria's done a lot of that work, a lot of the, permissions and everything. I just sit here in Melbourne, we're away from that. So, a lot of that work, even when we did, the first couple of installations, it has been quite difficult. So I feel like going forward, we really have, a great sort of precedent basically to move forward. And, I think going forward, it will mean that the work that we do will be sort of more meaningful. And we've just basically got a fantastic body of work to back up a lot of what we want to start testing next.
Great. Well, I think if there's any questions from the audience.
What do you think is some of the most imminent ecological detriments in the Sydney aquatic arena that you see will be in the near future, probably the most immediate detriment?
I'll just repeat that for the recording. What do you see as the most imminent ecological threats to the Sydney aquatic area in the near future? Close enough? Feels like a test.
That's a really great question. So I guess some of the current threats we have that we expect to continue, because it is such an urban harbour, we have a lot of non-native species in our harbour, so invasive pests that will then compete with native species for space to attach and grow on hard structures. We also are faced with issues like water quality. So poor water quality will become can be an issue and will become an issue in the future as well. So I guess kind of relating back to the science we've done to address those two kind of current and then also future threats. What we found is that actually by having these geometries that are based on natural features, we tend to see lower rates of colonization by non-native species on these structures. And also we've shown that the communities that these structures support actually help, they filter water more efficiently. So we're actually then kind of, so things like oysters and mussels naturally filter water and improve water quality. So then we're actually helping to hopefully improve water quality by having these structures as well. I guess going forward, we are seeing increasingly warming temperatures in the oceans, and actually Sydney is a really interesting area to try to address these questions because we're the biggest city in Australia. Sorry, Alex. And we're at this hotspot where we kind of see the changes in temperature actually happening here right in our harbour. So I guess I don't have the answers to your question, but it's something that we're constantly looking at. So trying to see what are the combined effects of urbanization and climate change on our harbour, and what can we do to try to maintain biodiversity. So yeah, great question.
Up the back.
Yeah, if I could just add to that, please. I think one of the worst scenarios we have are cyanobacterial blooms and harmful algal blooms. And for instance, I live near Homebush Bay, and Homebush Bay and Canada Bay were completely covered in over in the winter time. And it was just a brown mass, and I was quite surprised, or at least I thought that the oysters survived over that time period that they were smothered. So yeah, I think this is one of the things that we should be looking at and trying to even find organisms that will feed off to get rid of it.
Yeah, that's a great point. I'm not as familiar with harmful algal blooms, so I don't want to speak too much to it. But these habitat units do support, tend to facilitate things like oysters and mussels that I guess you said survive in that instance. And yeah, hopefully we'll have to maintain water quality. But yeah, that's a great thing for us to look into and consider. And again, you know, there's a lot of research at SIMS to look into those kinds of questions. Yeah, that's just not my expertise. Yeah.
Have you got any data to show, for instance, the McMahon Point living wall as opposed to the Drummoyne living wall? I noticed there's a big difference in the amount of organisms living there. Is that just during the time period that the wall has been placed up, or was it something else?
I'm just going to repeat that for the recording.
Oh, sorry.
So what were the kind of differences between the McMahon Point and what was the other one? Drummoyne. Drummoyne in terms of structure, but also what's starting to inhabitate, if that's a word.
Some data results.
Data results, yep.
Yes, I didn't include any slides in this talk today. So the picture that I showed of the Drummoyne Wharf, that was just after installation, so there really wasn't anything growing on the habitat panels yet. Whereas the ones from Milson's Point and McMahon's Point, that was after 24 months. So there's quite a lot of difference in what's been, you know, the time that they've been out and what's been able to recruit in that time. I guess when we were speaking with council about the Drummoyne Wharf, one thing we did raise that there is generally less biodiversity further up river. So potentially the benefits of having the panels installed there wouldn't be as great, simply because there's not as many species to recruit to the panels. So we don't have any data yet on what's living on them because it's only just now been about 6 months, and that's when we usually do our first survey. But actually we had a master's student who looked at some locations upriver using those smaller square tiles that we showed earlier. And she actually found, contrary to what we thought, that there might not be as much of a benefit because there's simply not as much biodiversity, that actually the complex design supported significantly more species than flat, like a flat panel. So that was very promising. But yeah, you can get in touch and we can provide some information on those exact numbers in the future.
Yeah, Chiswick Wharf has a very good, they're like not panels, but they're blocks. And they've got like hexagon shapes, and there's holes through every block, and the oysters have just grown up right over it. So I don't know how long it's been there, but it's quite significant.
So yeah, so that's actually those are our panels. So this one here,
Okay.
or sorry, it's can you switch to?
Oh yeah, sorry.
That's the one.
No.
No. Okay.
Chiswick Wharf I'm talking about.
Oh, okay. I'll have to check it out.
Have a look.
Yep.
Just in regards to 3D printing for Alex, what do you think is the next waves in technological advancement in 3D printing? Is it going to be speed of print or types of material? And do you think it's just based on, you know, prototyping phase, or will there be mass production applications for 3D printing in the future?
So great question regarding 3D printing directed towards you, Alex, which was, what do you see as the kind of the next wave of 3D printing? Do you see it being more about speed, variety of materials, still maintaining a kind of a focus on prototyping, or it being more of a mass production based technology?
Sure. So I mean, personally, I think it really depends on what type of technology, you know, that you're talking about. I think for the sort of work that I do, I mean, I'm obviously quite interested in more of the kind of construction 3D printing, like, you know, extruded concrete 3D printing, or you know, powder bed, sort of large scale powder bed 3D printing. And I mean, I was always a bit, you know, sort of not that interested in the extruded, say, concrete 3D printing. But even over the last like 2 years, I've been quite amazed at the kind of some of the sort of the scale that a lot of those extruded concrete printers are printing at, and even the different materials they're using. There's so many amazing designers that are, you know, printing with various like earth, rather than just concrete with cement as a binding agent, using like natural materials like earth. And I mean, there's so many incredible companies that are doing some really impressive things, like even 3D Wasp. I saw the other day, they've done this massive structure that is actually, I'm amazed at how quickly a lot of that has developed. So, I think extrusion, like large scale sort of mortar extrusion technology will be massive. I think I'm already seeing some incredible things. And I think as they start to develop techniques for being able to handle the overhang on structures, that will really open up some amazing possibilities with that technology. But I think, the larger scale powder bed printing, I think that there's going to be some impressive developments there as well. I think that's probably not, I think that to me, that seems to be, has really lagged behind extrusion concrete technology. But I mean, something that I'm particularly interested in as well is just like how, techniques for much larger scale, FDM plastic 3D printing, where you can, create basically digitally fabricated molding systems as well. I think, especially in the construction industry, I think that's going to be really interesting. And some of the stuff that we're kind of doing at the moment is just some of the developments with larger scale FDM plastic printing, how that can be used to create digitally fabricated molds. I think that's going to be really interesting. And already, I mean, when I finished uni in 2013, we didn't even have like a single printer that we really had access to. And I go back to the university workshop now, and there's just like hundreds of printers. So even that kind of whole like farm printing process is what I'm particularly interested in as well. So, yeah, but I mean, there's obviously so many other technologies that there's going to be massive, developments in, and especially in terms of speed and that sort of thing. But I'm personally most interested in the larger scale printing technologies.
Great. Any other questions? Oh, Dennis.
Yes, I think you mentioned a little bit about this, about the structures increasing biodiversity. I'm wondering, is there anything that the printed structures do better than or any other things that the printed structures do better than the organic, natural occurring walls? And yeah.
That's a great question. So when we go out and do our monitoring, we look at what's living on the habitat panels and compare that to an unmodified section of seawall and a natural section of shoreline. So far, I guess the idea is that eventually what's living on the habitat panels will be equal to what we see, or very close to what we see in a natural shoreline in terms of biodiversity, which includes things like species richness, species abundances. So far, the panels have far exceeded what we see on an unmodified section of seawall, but they're not quite the same as a natural shoreline. So I think in terms of I wouldn't say that any kind of as beautifully as these are designed and as valuable as they are in enhancing biodiversity in a very urban setting, nothing is going to beat a natural habitat. What would be really interesting though is kind of thinking ahead to climate change impacts, so increased storm events, increased wave energy from that, potentially natural structures or natural oyster reefs, mangroves won't be able to keep up with some of those events, so potentially augmenting those with these structures might help to then enhance the survival of species living in those natural structures. And that's actually, Alex has been involved in some work trying to create mangrove planters that then might help mangroves survive in these circumstances. So far they haven't done better than a natural habitat, but I think there's going to be increasing use of using these structures to try to protect natural habitats in the future. So yeah.
Any more questions?
I'm sort of interested in, I guess at the beginning, were people approaching you about this project to try things out, or did you really have to push with different councils or landowners, or to actually be able to test them? Like, was it you approaching people, or are people really coming to you to put these in different areas and try them out?
So that question was, how did this, in terms of permissions and access to these aquatic spaces, how is that kind of brokered between Sims and whoever the kind of land that these panels falls onto?
Yeah, so with our first installations, those were done in the North Sydney Council area, and actually I can't take credit for that, because for as long as some of these interventions have been trialed in Sydney Harbour, they've been in the North Sydney Council area. So there's just a legacy of kind of support for this type of research there. Once we had kind of established some of these sites and demonstrated that they were working, then other councils were much more receptive. I think, and part of it again, it comes back to awareness. So once councils are aware, they're super keen to get involved and try to find ways to make this happen. It's just a matter of saying, look at what we're doing, what we can do on your seawalls. So yes, initially it has been us approaching different councils asking, can we install these on your seawall? But since, recently it's more people coming to us asking how they can get involved and look for funding within council to try to make it happen or elsewhere. So yeah.
Awesome. So I think we'll wrap it up just about there, but I just wanted to ask if there's anything that you guys wanted to add, any final thoughts or plugs for where people can find you or follow the research or follow your practice or anything like that. Did you guys want to throw anything out there, or no?
Alex, you can go.
I mean, you can follow me on Instagram if you want.
Yeah, our project, Living Seawalls, has an Instagram and Twitter account. And we'll tag Alex too, but yeah, you can find him on those platforms. As I said, there's quite a lot of sites around the harbour, so one thing we really advocate for is for having signage at the site, so that sometimes happens a bit after the installation is complete. But yeah, hopefully you'll see some sites around the harbour, and we can provide those locations if you'd like as well, so yeah.
Awesome. Thank you both so much for being part of this, and it was really really lovely to hear about the whole project from its kind of germinal stages into where it's kind of hopefully heading into as well. So thank you to Maria and Alex. Thank you so much.
Thanks for having us.